Good morning, everybody. I am Richard Agbeyibor. I go by Coco. I am a major in the Air Force, and I am a flight test engineer. So today I'm here to tell you about flight test engineering and what we do here at Edwards Air Force Base, the center of the aerospace testing universe. And I'm also here to answer any questions you may have about any STEM topics. So bring it on. And again, the number is 707-412-8922. So I am a flight test engineer. You see me in a flight suit. I am not a military pilot. I am an airborne test conductor in the Air Force. I am a civilian pilot that flies as a hobby, but in the Air Force, really, my role is to plan, execute, and report on flight tests. So in the Air Force, I am considered an acquisitions officer. And acquisitions officers, really, they build, they buy, they sustain all the systems, all the equipment, all the airplanes, all the computers, everything we use in the Air Force to do our job. An acquisition officers gets it. And there are three types of acquisitions officers. So there are scientists, as you can imagine, engineers, as you can imagine, and program managers who really are the ones that coordinate all the science and engineering that we do and use their math skills to keep us on track to get all the equipment and all the systems we need to come out on time. I work at the Air Force Test Center, which is the organization in the Air Force that is responsible for developmental tests and evaluation of all the Air Force's air, space, and cyber systems. And so today I'd like to tell you a little bit about how I got into test and evaluation, what test and evaluation is, how I got into this job, and why it is I chose a career like this. And I'll tell you a little bit about all the cool types of work and cool tests and cool jobs I've gotten to do in my career so far. So you've heard me say test and evaluation a couple times. What does that really mean? Very simply, test and evaluation is really taking a system like an airplane and finding out how good it is or how not so good it is. So my job, our job here at Edwards Air Force Base is to take systems like airplanes and go figure out how fast they are, how high they can fly, how well they can turn and maneuver, or really how accurate they are at shooting things. So we get to do all of that here at Edwards Air Force Base. And you, at your house, you probably have a number of devices, computers, and all kinds of things around the house that when you open it up came with a user manual. And that user manual was written by a test and evaluation engineer. And it tells you what that thing can or cannot do. And that is very similar to what we do here at Edwards Air Force Base, the center of the aerospace testing universe, except after I do my test, I write a report and I send it to the program managers that I was talking to you about a little bit earlier. Now, I love my job. Why do I love my job? Because they pay me to take systems, aircrafts, and push them to their limits. And that can sound very dangerous, but we have developed over the years ways to do that in a very safe and reliable manner. And I learned to do all of that in engineering school. So engineering school had many steps to it, and I started out studying robotics for my bachelor's degree, and then decided I wanted to learn a little bit more about some specific part of that, and went to graduate school afterwards to learn how to do science and continue developing my understanding of science and engineering. And then after that, I got into test pilot school and really learned how to do flight test engineer, which is what I'm going to tell to you about today. So before I tell you about all the things that we do in flight tests, I kind of want to tell you a little bit about how and why I came to be here. So Every kid goes through a why phase in life, and they ask their parents 1,000 whys of why this, why that, and why this. And me, my poor parents, after my why phase, I went into the how phase of how does the TV work? How does the microwave work? How does the VCR work? And asked a ton of how questions. And my poor parents answered to the best of their abilities, but it got to a point where they stopped having concrete answers for me. So I went about discovering on my own, and I discovered through disassembly of all the little toys I could get my hands on. I took apart every toy I had and tried to put it back together. Took apart, unfortunately, all the electronics we had around the house, and took apart quite a number of VCRs, if you guys have seen VCRs, which your parents may have in the attic or in the basement somewhere. And couldn't put that back together, so decided I wanted to go to school and learn how to build things like that. So that's kind of where it spurred my interest in systems and machines and electronics and all things like that. So as a kid, I decided, okay, this is what I want to do when I grow up. I want to work with electronics. And I looked around and didn't really see anybody who really did this kind of work. So I looked beyond my immediate family. I looked to characters on TV. Question for you guys. How many of you are fans of James Bond? A new movie just came out, and I hope you go out to see it. Well, as a kid, I love James Bond. I love everything about James Bond. I love James Bond, the secret super spy agent man himself, but I also loved other characters in James Bond, particularly Q. And if you know who Q is the coolest man in that movie, in that series. Q is a quartermaster in James Bond, and Q builds all the toys, all the gadgets, all the cars, all the motorcycles, all the pens that James Bond uses, Q builds. And I wanted to be more like Q when I grew up. So I started looking for how to make my way to becoming Q as an adult. So in middle school is when I really got my start in shop class. So we had a woodworking class, and there I got to really start exercising my STEM chops. So I started learning to design and build and draw and make things that were conceptual in my head reality, and that was super fun. And then I got to high school, and I took all the math, all the science, every class, everywhere where I could learn a little bit more STEM. I went after it and learned a ton. But in high school, too, I became old enough to start working. So I got a job helping out at the local mechanic shop, and I love cars back then and to this day, and got to help out around the shop, got to learn how to work on cars. And then when I got a little bit older, I got a job at an electronics repair shop, where I learned to finally learn to repair those VCRs that I took apart when I was a kid. And when I got a little bit older, I got a job at Pep Boys selling parts, auto parts to customers. And that was rewarding in that I would help my customers who came into the shop diagnose their problem that they had on their vehicle and find the right part that would fix that problem for them. And that was really rewarding. And as I told you earlier, after high school, I went on to college to study more STEM, then went on to graduate school to study more STEM, and then went on to test pilot school. And to this day, I continue learning. Like every day, I learn something new, and this process never ends, and super fun to grow and to discover continuously. So I encourage you to learn, not just in school, but outside of school. Continue learning all the time. I work at Edwards Air Force Base in California, if you're not local. And here at Edwards Air Force Base, we have as our primary mission flight test engineering. And I've gotten to do a lot of cool work here at Edwards in different projects. I'm going to tell you really quickly about 3 technologies that I've gotten to test here at Edwards as a flight test engineer. I'll tell you a little bit about our joint all-domain work that I do in Orange Flag. I'll tell you about the work I've done on testing autonomous systems, and I'll tell you about the work I've done on counter small UAS systems. So we do an exercise here called Orange Flag, which is this big exercise event where we bring together 50 or more airplanes and we put them all in the sky at the same time, and we do compatibility and interoperability testing. So I just use a complicated term, compatibility and interoperability testing. What does that mean? I'm going to tell you a little bit more, but if you don't quite get it, send in questions to 707-412-8922. So you have a number of devices around the house. You have the computer on which you're probably watching me right now. You have your iPad, you have your phone, you have your television screen. And when you open the box and you plug them in, they all probably worked as advertised. But sometimes you want to connect them to each other. You may want to connect the computer to the TV or the iPad to the TV. And you'll discover when you try to do that they all have different ports. Some have VGA ports, some have HDMI, DVI, PCI, some have Lightning ports, USB-C, mini USB, all of these ports. And when you try to plug them together, it doesn't sometimes work as you would like. And that is the same with our aircraft. We try to get our F-16s to talk to our F-18s, talk to our F-22s, F-35s, to our U-2s, to our satellites, to our ships, and they sometimes aren't able to talk to each other right off the bat. So we do compatibility and interoperability testing to try to figure out how to get them to talk to each other and to work with each other better, because our mission, our warfighting mission, depends on every member of the team being able to contribute their specialty. So that's why we do compatibility and interoperability testing. The next type of work that I do is testing of autonomous systems. So what is autonomy? You've probably heard a bit about autonomy, which is just very simply computers being able to independently do tasks on their own without human intervention. And autonomy is starting to be everywhere now. You probably got it in your parents' car. So a very simple form of autonomy is adaptive cruise control, which you tell the car, hey, I want you to go this speed. And the car, depending on traffic, will either slow down or accelerate to be able to reach that speed. Now, that's level 1 autonomy. Now, add on top of that adaptive cruise control, automatic lane keeping, now where the car will come to a bend in the road and it will turn the wheel left or right to follow the road and stay in the center of the lane. And beyond that level 2 autonomy, there are more complicated pieces of autonomy where the car will change lanes or do much more complicated navigation tasks all on its own. Well, that's in your world, and that's in autos and cars, and we, the Air Force, want that for our airplanes too, because our pilots are very, very busy all the time, and they could use the help from the computer to help take off some of the tasks, offload some of the work from them, so they can focus their minds on other things. The third piece of work that I want to talk to you about today is counter small UAS. So you've probably heard the term UAS. What does that mean? It stands for Unmanned Aerial System, or UAV, Unmanned Aerial Vehicle, which is simply a drone. And you've probably seen drones flying around. You may have a drone around the house, and you know that those drones, although they're fun to use, to fly, they can be dangerous. And for example, it's happened to me. I hope it's not happened to any of you. If you get your finger caught in the propeller of a drone, it can hurt you pretty bad, or even cut you and damage your finger pretty badly. And that's for a small drone that you can buy at Best Buy or your local neighborhood electronics shop. Now, imagine that drone being flown into a person. Now, that would hurt them even more than just getting a finger caught in a propeller. Imagine that drone being flown into a car that's driving down the road. It would injure the passengers and damage the car pretty badly. Or imagine a bigger drone being flown into a building. It could damage that building. And bad guys know this, and bad guys are out there trying to use drones to cause harm and damage. So we in the Air Force are trying to develop systems to stop these drones, and we call those technologies counter small UAS systems. And I'll tell you really quickly about three ways we try to stop them. One is kinetic. The other is through directed energy or laser. And the third one is through electronic warfare, electronic attack. So kinetic is very simple. You try to hit that drone out of the sky. And I've gone to do that here at Edwards Air Force Base by shooting grenades at drones and blowing them out of the sky. And it is pretty awesome work that I can't believe they pay me to do. The other type is directed energy, which is where you shoot a laser at it. So some of you may have some lasers at home, laser pointers probably, that shoot green or red light. And you've been told by your parents not to point at somebody's face because it can damage their eyes. Well, we have bigger, like really big lasers here in the Air Force that actually burn holes through things. And we use those lasers to smoke these UAVs out of the sky. And I've gotten to do a lot of that work here, shooting and burning, smoking out drones out of the sky. The third way we try to take them out is what's called electronic attack or electronic warfare, which is we use what are almost like death rays to knock them out of the sky. So death rays are these things that look like guns that seem almost magical because they shoot these electronic EW or RF radio frequency rays out of them. And about 100, we got them because 100 years ago, this physicist, James Clerk Maxwell, came up with these equations called the Maxwell equations that we've used to figure out how to shoot invisible rays out of antennas. And we use that to knock out drones in the sky. So that's very quickly some of the things that I've worked on here as a flight test engineer at Edwards Air Force Base. And I am going to open it up to questions in a couple minutes. But before I do that, I want to leave you with 3 things I want you to do for you to get ready to help us develop our science and technology. I want you to work on 3 things. I want you to work on your mind, I want you to work on your hand, and I want you to work on your teamwork skills. So your mind, to do what we do in STEM, you're going to need to know as much math and as much science. So learn as much math, as much science as you can, as much as you can hold in your head, because I use it every day, and you will definitely need all that knowledge when you get here or get to another job where you're doing science and technology and engineering and math. The other thing is I want you to work on your hands. I want you to work on your hand-eye coordination. I want you to work on your design skills. I want you to help out your parents around the house whenever they're manually working on something, changing a light bulb, working on the car, fixing a cabinet, whatever you can to develop those hands-on skills, please do. And finally, I want you to work on your teamwork skills, because nothing we do here at Edwards Air Force Base or in the Air Force in general can be done by one person. Our mission is bigger than any individual, and it takes teams and it takes teamwork to do it properly. So that is very quickly a little bit about what I do, what we do here at Edwards Air Force Base in flight test engineering. And I am looking forward to answering some of your questions.
All right, sir, we got a few questions for you. So first off, we heard that there's this amazing opportunity that you've had recently and was wondering if you could tell us a little bit about that.
Yeah, absolutely. So I would be remiss not to tell you about one of my dreams, which is to become an astronaut. So I've applied to the Astronaut Corps, and I have made it pretty far in the process. So every 3 or 4 years, NASA releases an announcement telling people, hey, we're hiring for the Astronaut Corps, so apply if you're interested. And last year in March, I threw my name in the hat and have gotten a call from NASA to come interview in person at the Johnson Space Center. So I went for a first round of interviews back in May and just came back recently from the final round of interviews at the Johnson Space Center, where they evaluate us both mentally, physically, psychologically, to try to find the right kind of people to join the Astronaut Corps. And I've been fascinated by space for a long, long time, for as long as I can remember. and I'm looking to get hired by NASA to join their team and help advance space exploration and space science.
Awesome. All right, so we have another question. How can a fan of aviation in their late 20s join the Air Force as a pilot, and is that even possible?
Oh yeah, absolutely. We are always hiring, especially for pilots. We want you, if you're qualified, to try out to become a pilot in the Air Force. So go to your local recruiter and tell them about your interests, and they'll tell you about all that you need to do to join the Air Force and become a pilot in the Air Force. And I would ask you, if you join the Air Force and become a pilot or are interested in that, consider becoming a test pilot or a test engineer if you are not one of the ones that want to become a test pilot. Because as a test engineer, I get to fly in airplanes as well. I conduct tests from the back seat of fighter jets or from the passenger seat of larger aircraft, and fly and wear flight suits to work, which is quite liberating. So we're always hiring. Go to your local recruiter or contact us, and we'll try to get you ways or information to help you realize that dream.
Awesome. Okay, so another question we have is, what has been your greatest challenge in achieving your goals?
Anything you do that's worthwhile will be challenging, because if we're easy, everybody would be doing it. And so my greatest challenges have been overcoming some of the academics that it takes to get here. And there's a lot of math out there. There's a lot of science out there, and it takes quite some work, some tenacity to learn it all, or not all, but what you need. So there have been some courses I've taken where it took a lot of practice before I could really understand the concepts. Test pilot school, for example, was one of the biggest challenges for me, because I spent the first 6 years of my education learning about electrons and electronics and software. And then I switched into flight tests, which is mostly about aerospace science and flight sciences. And it took me quite a lot of extra effort to learn those fundamentals and get to the place I am today. But I got through it, so can you.
Okay, next question. Who did you look up to as a child?
Oh man, I had all kinds of heroes. Anybody who was doing something cool, I wanted to be like when I was a kid. I told you about Q from James Bond, who was one of my fictional heroes. In real life, and there are people like Mr. Bill Gates that were out there building companies that were bringing technology into the homes of everyday people. And I aspire to do that one day, and make technology accessible to all. So people like that, titans of industry, were my heroes growing up. People who are designers, people who are inventors are my heroes. And to this day, I continue to try to get better so that I can grow up and be like them.
Okay, the next question is, if you could explain what Gforce is.
Oh yeah, so Gforce, have you been to on a roller coaster? You have definitely experienced Gforce if you have been on a roller coaster. So if you've been to Six Flags or Disneyland or Disney World or anywhere else where there are roller coasters, you'll find that when you are accelerated downhill and then you come back up, you feel super heavy, like you're getting sucked into the seat. And that's because of G-force. And G-force is just really acceleration that is greater than normal gravity. And you feel it most when you accelerate upwards, and you get to see that in roller coasters like I just mentioned, or also in airplanes, where you literally have multiples of your body weight acting on your body. In our fighter jets, we experience G-forces up to 9 Gs, and that is feeling 9 times as heavy as you normally weight. So under G conditions or under accelerations, trying to lift your arm, it weighs 9 times as much. So you really have to strain to move your body around. And there are some dangers to experiencing G-force. Another thing that it does is that it not just pulls your whole body, but it also pulls the blood in your body towards the earth, and that can remove some of the blood that you need to stay conscious from your brain and can lead to what's called G-lock, which is a dangerous condition. But we train to mitigate those effects and still go out there and fly fighter jets in a safe way.
Okay, next question is, how would you inspire students to join the Air Force and get into fields that require math and science? And what are some of the careers that you know they can get into?
Oh, the Air Force at its core is about technology. Any job in the Air Force is related to STEM. So I would encourage you to do what you love the most that is related to science, technology, engineering, math, art, design, any of that, all of that. We could use somebody that's as talented and that's motivated and that's as passionate as you are. So I would recommend that if you are still in grade school, that you go about doing the best that you can to learn as much as you can so that you can join our team and help contribute to our mission and help keep us all safe in the future.
Okay, next question is, do you have a favorite plane and why is that your favorite plane?
Oh man, this may sound a little crazy, but I get jealous when I see birds fly. Like birds can just unfold their wings and fly, which we human beings cannot do. And when I look at airplanes flying, to me, the B-2 looks the most like a flying bird. I love the flying wing design. And the B-2 is my current most favorite airplane. And I say current most favorite airplane because we have another flying wing design, the B-21, coming out soon that is a flying wing. And I'm looking forward to seeing it fly and soar in the skies above Edwards Air Force Base.
Okay. This goes back to high school. Which was your most difficult class in high school?
I enjoyed every class in high school, but I have to say some of the literature courses were some of my most challenging because there were parts to it that used skills that were not my strength. So the literary analysis was challenging for me in high school, but I now realize that this day and age that was just practice for really analyzing the real world, and fiction gives us kind of a predictable, contained way to analyze dialogue interaction between different characters, and the real world is much more complicated than that. So take it seriously. Make the most of your literature classes because it will help you out in life in general.
Okay, well, another question for you. Do you ever find out at the last minute that you have to fly? And if so, how much time do you actually have to get ready?
We definitely have missions that come up unannounced, and we do our best to be ready for those. And I think I can get ready in about 15, 20 minutes, depending on how much lead time I have or how much of a warning, how prepared I am, what alert status.
Coco, I'm sorry to interrupt this broadcast, but we've just received an urgent message from the 416th Test Squadron. They've got an F-16 out on the ramp with the engine running, and they've got an open back seat, and they desperately need a flight test engineer.
All right. I'm on my way, TJ.
Thanks, Coco. We appreciate hearing from you today, and thank all of you for tuning in today to the broadcast to hear about the exciting opportunities that are available to you in the STEM career field. On behalf of the Edwards STEM Outreach Program, we want to thank you and remind you that every day this week at 10 a.m. and 1 p.m. Pacific Standard Time, we'll be having more broadcasts where you can hear from